All right, so we're continuing Geometry A, Quiz 5, version 1 on similar triangles, but now we're to problems 3 and 4. Again, if you have the paper in front of you, you can read that it says each pair of triangles is similar. Find the value for x. So starting with number 3, we want to talk about corresponding sides. We did that on number 1. We talked about sides that correspond. So I'm really interested in x. That's really what I'm interested in. So I'll say, okay, so x is going to correspond to one of the sides in the other triangle. It looks to be bigger, so maybe this is zoomed in and that's zoomed out. But that's the idea of similar triangles. And so if you remember, I erased it, but I shouldn't have. Corresponding sides are opposite from equal angles. Corresponding sides are opposite from equal angles. So, all right, so x is a side length, and I can talk about the angle that it's opposite. And if I go across the triangle, I go, all right, so we've got a 76-degree angle here. So in the other triangle, the corresponding side to x corresponds to one of these sides. It's going to be opposite the 76-degree angle. And I go, oh, perfect. Look right there. There's the 76-degree angle. So in this triangle, what's opposite? 72. Okay, so that's a pair of corresponding sides or side lengths. Okay. Now, it might be a little confusing because you might say, well, okay, we've got the 60, the 50. We have 3 other numbers. We're only going to need 2 more. We're gonna talk about another side length corresponds to another side length. 2 more corresponding sides, or another pair of corresponding sides. Now, remember that we want to be consistent. So whereas x came from, you might call it the little triangle or the small triangle. So here I go, okay, so in the little triangle, I've only got one other side length. So I'll take that. So it'll be 9. That's the only option I have. I don't know this side length, so it's not going to help me. But I go, okay, so 9 corresponds, which side here corresponds to the 9? And whoops, I forgot to trace my 72 with blue there. Again, if that color coding helps you, go for it. But I go, okay, so 9, I don't know the angle it's opposite. We're looking for corresponding sides to be opposite equal angles. So I go, well, but you know what? I can use the triangle angle sum. If I know 2 angles in a triangle, I can figure out the third. So if we take 180 total for all 3, we can figure out that this is going to be 47 degrees. So that was the 180 total minus the 76 minus the 57. That gives me 47 degrees there. And look here in the other triangle, there's a 47-degree angle. So 9 opposite 47 degrees here is going to correspond to 54 opposite 47 degrees there. Okay, so got 2 pairs of corresponding side lengths. And if you can get that, in my opinion, the hard part's over. There's still plenty to do, but it's just kind of automatic. I'm just going to fill in on the notes here. X and 72 are both opposite from 76 degrees. And then 9 and 54 are both opposite 47 degrees. That's how I know they're corresponding, these pairs of corresponding sides. But yeah, if you can get that much, in my opinion, the hard part's over. We're going to make a proportion, and the proportion just jumps out at me. I don't know about you. It's basically, there's a fraction and there's a fraction. I'm just going to set these equal. X over 9 equals 72 over 54. And now I just have to cross multiply and divide. X equals, multiply diagonally, 9 times 72, or 72 times 9, and then divide by the number you didn't multiply with, and I come up with 12 when I do that. Okay. We're not told what the units are, if these are feet or inches or centimeters. So if you want to challenge yourself to be a better math student, you can just say 12 units. Units is just very general. I don't know what it is, but whatever you're measuring, it's 12 of those. Okay. So yeah, again, that idea. Corresponding sides are opposite from equal angles. And then if you write it out like that, make sure you're just being consistent. I started with the little triangle first on each of these, big triangle second, matching up those corresponding sides, and it gets right into the proportion. Number 4 is a little more difficult because we only have the 90-degree angles. We're not given any other angles. So you might be like, well, hey, remember how we figured out that was 47 degrees? We can't do that here. I can tell you that you got 90 and 90, but the other 4 angles, 1, 2, 3, 4, it might seem like we're stuck. But keep in mind, we have vertical angles. These are vertical angles, right here and right here. These angles are gonna be the same. I don't know what the measurement is, but it's gonna be the same. So I'll show you a couple different ways you could do this. The first way is probably not generally a good idea. That is to say, pretend you know the angle measurement. I don't know, pretend this is 30 degrees. So we'll just put it up there. Pretend they're each 30 degrees. So you could say, well, it's 30 degrees here and it's 30 degrees here. I don't know. The good news is we're not going to calculate with the 30 degrees, so it's okay to pretend this. I just need it so I can do the whole corresponding sides, getting those equal angles. Well, it turns out if that's 30 degrees, these two are vertical with each other, so if one is 30, the other's 30. And then your other angles are going to be 60 degrees, because that would be 180 minus the right angle, that's 90, minus the 30 that we're pretending is going to give you 60 degrees there. This would be the same calculation, same result, 60 degrees. So now I can talk about my corresponding sides. So I can say, all right, again, I'm going to look at what I'm looking for. I'm going to try to start with that. So I would say, all right, in this diagram, x corresponds to a side in the other triangle. Well, x is opposite, I'll do x in blue again, x is opposite from the right angle. So the corresponding side in the other triangle will be opposite from the right angle. So that's going to be the 5. So x corresponds to 5. They're both opposite the 90-degree angle. That's how I know they correspond. Again, corresponding sides are opposite from equal angles. And then again, you could say, well, how do you know if we should use the 4, the 3, or the 60? I would say, let's stick in the same triangle. Let's stay with the, is this one bigger? This time it looks like x comes from the big triangle. And then 5 looks like it comes from a triangle that's smaller. So again, zoomed in, zoomed out, possibly rotated. That's the idea of similar triangles, similar figures. So I'm going to stick with the same triangle as x, and so the only side length I have to use is the 60. And I probably should have picked different angle measures, because now it's like 60 degrees and a side length of 60. Remember, the sides are different from the angles. So a side length of 60 units, that corresponds to either the 4 or the 3, I'm guessing. How do I know if the 60 here corresponds to the 4 or the 3? Well, we look at the angle that we're opposite from. So the side length of 60 is opposite a 60-degree angle that we were pretending. So here I go, all right, so let's use the same angle and go opposite, and we get the side length of 3. So 60 corresponds to the 3. They're both opposite the pretend 60 degrees. And again, if you can get there, I think the hard part's over. Now I'm basically just going to make a proportion, x over 60 and 5 over 3. Cross multiply and divide. 60 times 5, divide by 3, and I believe that's 100. That's what I have written down anyways. So So that's coming back here. And whoops, again, if you want to challenge yourself, 100 units. So we don't have naked numbers. So yeah, so you can back that video up if you want. For anyone that's like, well, how are we just allowed to do this? Pretend it's 30 degrees or pick a different number. Again, we should be careful of it, but I didn't calculate with 30 degrees. There was nowhere in my work where I was like, oh, 30 degrees, that would have been bad, because I would have been like, I was just pretending it was 30 degrees. Even though I calculated with 60, it was the side length of 60, not the 60 degrees. So for those that are interested, you can keep watching to be like, well, if we can't pretend that it's 30, or if we shouldn't, then what do you do? So what you might do is you might just say your vertical angles, maybe you want to use a variable. So maybe you go, don't use x, because x is already in use. So maybe I call this y degrees. But this is going to be the same because they're vertical angles. And then this angle, if it's y degrees here, this one's a little trickier. It'd be 180 minus 90 minus y, 180 total minus the 90 degrees I know minus whatever this is. And that simplifies to 90 minus y. You can subtract 180 minus 90, but then you're still supposed to take away the y. And we would just leave it like that. Here would be the same thing. This would be 90 minus y. And then you could say 60 corresponds to 3 because they're both opposite from an angle that measures 90 minus y degrees. So yeah, so that's the technical thing there. But yeah, it doesn't matter for our purposes right now. It doesn't matter what these angle measurements are. It only matters that they're equal. And it matters that these are equal because, again, corresponding sides are opposite from equal angles. Okay. We'll do one more video for number 5, but that's it for 3 and 4.